Hi, welcome to video 8.7b part 2, another indeterminate form, infinity minus infinity.
Or negative infinity, remember the thing from last year, positive over 0 through positive, positive over 0 through negative. So most likely you're going to get infinity minus infinity because you're going to have a fraction minus a fraction, such as this case right here. So if I approach from the right, I have this is 10 over 0 minus 3 over 0, so that's going to either give infinity or negative infinity, as will that. So I have a positive 10, my denominator is approaching 0 through positives, then I have minus, then I have a positive 3, and of course I'm squaring this, so that'll be 0 through positives. So what happens is, sure enough, we get infinity minus infinity. And the way to solve this problem is to simply combine those two fractions. Just find a common denominator and combine them. And now when you substitute in, you'll have negative 3 over 0, which is a negative over 0 through positives because of the square, and that'll give negative infinity. Okay, if some would ask for the limit as x approaches 0 from the left, the only difference would be this would approach 0 through negatives. This is squared, so it would still be through positives. It would actually be a much easier problem because this is negative infinity minus positive infinity, but that ends up being negative infinity minus negative infinity, which is negative infinity. Okay, so here's another example. 10 over 0 is going to give infinity or negative infinity, so is 3 over 0, non-zero over 0. 0 through positive, 0 through positive, you end up with infinity plus infinity, and of course that is not an indeterminate form, that's just infinity. Looking at number 26, they have the limit as x goes to infinity of x minus 6 over x squared plus 4x plus 7. So the first thing you'll do is plug in infinity. Infinity minus 6 is infinity. Infinity squared is infinity. 4 times infinity is infinity. Infinity plus infinity is infinity plus 7 is infinity. So we do have infinity over infinity. We're going to use L'Hopital's rule. Derivative of the numerator is 1. Derivative of the denominator is 2x plus 4. And now again, you're just going to substitute. You're going to have 1 over 2 times infinity plus 4. 2 times infinity is infinity. Infinity plus 4 is infinity. 1 divided by infinity would be 0. Number 34, this is a weird one. If you substitute, you'll get the sign of infinity. Now, the sign of infinity, it's not like the graph of y equals sine x goes to a particular number as you go to the right. And this would end up being x, which is infinity minus pi, which would be infinity. What happens is the thing simply doesn't exist, and the reason is because as I move further and further and further to the right, my sign of x does not approach a particular number. It just keeps bouncing back and forth between all the real values between negative 1 and 1. Limit as x goes to infinity of the ln of x to the 4th over x cubed. So y equals ln x because the base is e bigger than 1 rises. So you can see from the graph that y equals ln of x to the 4th is still going to rise forever, and therefore the limit of the numerator will be infinity over infinity cubed, which is infinity. So we have a situation where we have to deal with that. So one of the things we can do, of course, because we got infinity over infinity, is use L'Hopital. So I'm going to take the derivative of the numerator. The derivative of the ln of a thing is 1 over the thing times the derivative of the thing. The derivative of x cubed is just 3x squared. You'll simplify that, and you'll end up with 4 over 3x cubed. Plug in infinity. Oh, I'm so sorry. You end up with 4 over infinity, which is 0. Okay, so here's another one. Limit as x goes to infinity of x times the tan of 1 over x. So I replace x by infinity. When I replace x by infinity here, I have 1 over infinity, which is 0. The tangent of 0 you should know is 0, so we're going to need to use the reciprocal deal on here. So I'm going to leave the x where it is. Again, I'm going to change times the tan of 1 over x and change it to divided by 1 over tan. It's equivalent. 1 over tan is cotan. And again, the cotan of 1 over infinity, which is the cotan of 0, does not exist. It goes up. Cotan of 0 is, well, as x approaches 0 from the right, it's infinity, and from the left, it's negative infinity. So it simply doesn't exist. Limit as x approaches 2 from the right of this fraction. You'll notice that this factors into x plus 2x minus 2. So if I do plug in 2, of course, I get 1 over 0. But the denominator is a positive times 0 through positives, and that was positive. So a positive, and a positive will give a positive infinity. Minus, now here I'm going to approach 2 from the right. So what happens is, if I plug in 2, I get the square root of 1, which is 1, over 0. So I get 1 over 0, which is a non-zero over 0, which is going to give infinity or negative infinity. I got 1, which is positive, and I'm approaching 0 through positives. Again, that's the same denominator. So you can see that 2 plus 2 is positive 4. 2 minus 2 is approaching 0. Since I'm approaching 2 from the right, which would be 2.1 minus 2 would be through positives. So in each case, I get a positive over 0 through positive, which is infinity in each case, but there's a subtraction between them, so I have to combine the two fractions. And that's all it is. You basically simply add the fractions together. Now when I plug in 2, I'm going to get 2 minus 1 is 1, square root of 1 is 1, 1 minus 1 is 0, 2 squared minus 4 is 0. I can finally use L'Hopital's rule. So I'm going to take the derivative of the top, which is 0. This is, of course, x minus 1 to the half, so the derivative is minus a half, x minus 1 to the negative a half times the derivative of this. And the derivative of the bottom is 2x. So, simplifying all that, the 1/2 over 2, the 0's gone, the 1/2 over 2 becomes 1/4. The x minus 1 to the negative a half becomes over the square root of x minus 1. Now I will plug in 2 for x. I plug in 2 for x here. 2 minus 1 is 1, and I end up with an answer of negative 1/8.